This is a 500 kilowatt Barra, and in this video we'll be bolting the Barra to this ZF8 speed to this Patrol transfer case. Once it's all bolted together, we're going to put it into this car, which is a 40 series on a heavily modified 80 series chassis. We'll be using this Bellhousing adapter, which we make from scratch, and also this transfer case adapter from Fusion Fab Industries.
And in this video, we're going to take you through the design and manufacturing process for a custom Bellhousing adapter before bolting everything together, finding the right position for the engine, and making a custom crossmember as well as engine mounts. Throughout all this, we'll be explaining why we picked a ZF8 speed and a Barra for this build. The first step to all of this is making a Bellhousing adapter. The Barra originally came with the ZF6 speed, which is a different bolt pattern to the ZF8 speed we're using for this build. So we need an adapter plate to bolt it all up. There's an existing product on the market, but we want to design a slimline version to help packaging for this build, as well as some other future builds we have in mind. I've personally never had any experience making driveline adapters, so we've called in the big guns Ash from Fusion Fab Industries to help us out. Ash specialises in M57 conversions for patrols and driveline adapters for the ZF8 and 6-speed transmissions. Be sure to check out Fusion Fab if you're looking to upgrade the motor in your patrol, as they're always releasing new products. We'll be designing the adapter in CAD, so the first step is to 3D scan everything. I'll leave you here with Ash so he can talk you through the process.
Hey guys, Ash from Fusion Fab Industries. Richard's invited me over today to LCS 4-wheel drive to scan George's Barra for a new build that they're working on. Let's get started. Spray the development spray on the engine just to give us a matte white finish, just for the scanner to pick up, just because it doesn't like black or shiny or glary surfaces. Putting a little bit of tracking process in, we'll just follow and keep up with the features that it can see on the screen there. If you pan over to the screen, you can see that we have a quality indicator is what it's called. So the green section of the scan is good quality, so the software is happy with what it sees, and all of the point clouds that it has, it's sufficient enough. The red sections, you know, they're there, but we need to go back over them and just add a bit more cloud point data. This scanner can vary, but we've got the resolution set to 0.2mm today. Yeah, so this is an optic scanner, so it does use cameras and lights as opposed to lasers or crosshatch laser. This is a usable scan now. As you can see, so we've got a colourful textured pattern, and then we've also got, we'll turn that off, and you can also see that we've got a usable mesh that we can now put into SolidWorks, ready for product development and rendering.
The next step is to put it all in CAD and design the adapter, but first let's talk about some of the advantages of the ZF8 speed and why we've chosen it over a ZF6 speed, which does come stock behind a Barra. Let me just preface this all with, I have a ZF6 speed and it works extremely well. It's one of the best 6-speed transmissions on the market, so why are we even entertaining an upgrade to an 8-speed if we can just bolt on a ZF6 speed and be done with it? I love data, so the first thing I did was an analysis purely based on ratios between the RE4, which was the transmission we were initially going to use, the ZF6 and the ZF8 speed, to see if we really need those 2 extra gears. Here's a table for speed versus RPMs, assuming we're in high range, have 4:3 diff ratios and 35-inch tyres. At 1000 RPM or more or less idle, we'd be travelling at 14 Ks with the RE4, 9 with the ZF6 and 8 with the ZF8 speed, meaning there's essentially no difference in ratios at the bottom end. And now let's look at top gear 6000 RPM, which is pretty much top speed. With an RE4, we'd only get to a measly 241 Ks an hour, the ZF6 would get to 336 and the ZF8 would get to 348, meaning there's around a 4% difference between the 8 and the 6 at the top speed, which is next to nothing. And from my experience, after clocking up 40,000 Ks on my ZF6 speed, there's never a shortage of power in the middle gears either. So what I'm saying is, from a ratio perspective, there's no real need for the 2 extra gears behind a Barra, which has a pretty wide band of usable power and torque. It's going to come close to an extra 12 grand to put an 8-speed behind the Barra compared to a ZF6 speed, so it's not exactly a cheap exercise either. So now you're probably wondering, why even bother? Well, here are some of the advantages of the 8-speed box. The ZF8 speed has a completely different internal design to the ZF6 speed. It's said to use 12% less fuel than my ZF6 speed due to this design. The shift times are improved as well. At 200 millisecond per shift, it could potentially shave a second off from a 0 to 100 time compared to my 6-speed. The 8-speed can also shift in a non-sequential manner, meaning skipping gears. It can also handle a huge range of input torque from 300 to 700 Newton meters in its stock form. And then we get to the extra features the 8-speed has, like trans brake, clutch by wire, and also more tuning capability. The ZF8 is widely regarded as the best automatic transmission of all time and continually gets refined and improved. You can find it in other brands as well, such as BMW, Jag, Audi, Land Rover, Rolls-Royce, Volkswagen, Jeep, Lamborghini, Porsche, Bentley, to name a few. We've never driven a ZF 8-speed behind a Barra ourselves, but if you're a regular viewer of this channel, you'll know we're all about testing our vehicles pretty thoroughly, and we're going to report back with all our findings.
We're down at Fusion Fab Industries today, and we are comparing the ZF6 to the ZF8. Now, one of the problems we face is the starter motor location. So you can see here on the casting of the ZF8 that the starter motor was initially down here and the sump is recessed on the M57 to suit, whereas on the 6-speed, it just bolts up to the Barra and is sort of right next to the block. So one of the problems we have is actually packaging a starter motor onto the adapter for an 8-speed. There is an existing adapter for this 8-speed on the market. Now, what they've done to overcome this problem is make it quite thick. One of the big problems we face with a 4580 build is the length of the driveline. We want it to be as short as possible because the motors move so far back in an 80 series chassis that we have dramas with the tail shaft angle, and I've gone through that on my build. So what we're going to do on this adapter is make it a bit more compact, and what that'll mean is actually cutting out a portion of the bell housing, and then we're going to have to make a cover to put back over it. Now we're looking at the back of the 8HP70, and you can see the output shaft is a little bit longer than the ZF 6-speed.
Here's a comparison table between the ZF6 and the ZF8 driveline lengths. By the way, the 8-speed we're talking about is out of a BMW X5 with an N57 engine, and that's what we'll be using for this build. As I mentioned, the bell housing adapter we're proposing to design will be slimline, coming in at 19mm. The ZF8 is 8mm longer than the ZF6, and the transfer case adapter has to be longer on the back of a ZF8 due to that longer shaft length. Therefore, the overall length using an 8-speed on the back of a barrel with this setup will be 50mm longer.
Already we're facing an increased driveline length using the 8-speed box. So we're trying to do everything we can to package the driveline and make it as short as possible, and that's going to reflect in our bell housing adapter design.
With all of that in mind, let's start designing this bell housing adapter.
It's important to have it aligned for when we do any drawing. We always have an axis or a reference point, which will be this, in this instance, the center line of the crankshaft just there. Now that we've got the scan fully aligned, we can actually start plotting all our holes. Here we have 8HP70 scan from previous. So we've got these two aligned into SolidWorks together. So that is probably going to be our distance between the block and the transmission. So we'll just go to a section view and we'll just see, mainly just for reference, just to sort of see that we don't have any interference. There's no clashing of spigots or the nose piece of the converter. So now we'll start aligning our adapter. A good thing to note as well is what I like to do is to get our spacing done first. So one thing to consider when we set up our distance between our transmission and the back of our engine is basically crankshaft protrusion. So we can see that the crankshaft does protrude out quite a fair way past the back of the block. So we just need to take that into consideration that we're not going to crash into the converter.
Ash then got to work on the adapter design. To do this, he had to consider a lot of things, and it was quite challenging to make sure nothing would foul when it was all bolted up. Due to the slim design we're chasing, we'll have to make our own ring gear and flex plate as well, which we'll cover in a future episode. Once the design was done, the next stage was to 3D print a prototype, and here's a simulation of the 3D print which is about to take place. Now Ash is setting up the print on the Fusion Fab 3D printer.
So now it's currently got its outside profile. This will be the inside profile. So there we go. Well, hopefully the first layer will look pretty good. And
George, this is the final colour for your adapter, by the way. We're going to anodise it.
yeah, we'll anodise it. I think we should anodise it.
3D printing technology has rapidly improved over the last decade. Something like this will take 25 hours to complete. It will be printed from PET plastic, and the resolution will be good enough to put captive threads in it so we can test fit all the bolts. We could obviously go straight to machining billet aluminium. However, if you were to make a mistake, it would be pretty costly. 3D printing is inexpensive, rapid, and great for prototyping this sort of thing.
25.5 hours later, got the prototype printed of the Barra BMW ZF8 bell housing adapter. Alrighty.
Really, really cool.
Probably
Good finish. Cool, man.
Very, very cool.
It does print a thread. Just run a tap down it just to clean it out. And we can clearly just run a bolt into it. Like it's tight.
Yeah.
And I wouldn't rely heavily on it. Got some dowels, nice tight fit. I'll meet you over at the transmission and we'll fit him on there. So we'll line the dowels up. As you can tell, this mounting hole here, we're going to have to chop the back of this out just to allow for the starter motor. These are the compromises that we have to have a slightly thinner bell housing adapter. So yeah, we'll make up a little cap that goes over the back of that. All bolts go in.
Now we've checked the 3D print bell housing adapter works on the 8-speed, we can test fit it to the Barra. George is test fitting it to the back of the Barra and it's all looking pretty good so far. Next step is to make it out of billet. This is a 3-axis vertical mill and you can see here that the 6061 aluminium billet stock is clamped down to the machine table. It's a 2-operation part, meaning the part has to be flipped over and machined from the backside once the front's done. The billet bell housing adapter is now complete. Look at that shiny machine billet. Damn, that does look pretty good. Now it's time to bolt it all up, but first, let me talk about the components we're using for this build. For those of you who aren't familiar with a Barra, it's a 4-litre inline 6-cylinder engine proudly developed and manufactured in Geelong, Australia. If you're doing an engine conversion, they're pretty hard to look past. They're incredibly reliable, dirt cheap. They also have a heap of readily available spare parts and you can make big power for a relatively low cost. Personally, I've been running a Barra in my Land Cruiser for the past 2 years and it's clocked up over 40,000 hassle-free kilometres and I absolutely love it. With that in mind, let's have a look at the Barra we're using for this build. It's come out of a Barra Swap Patrol.
This is mainly a B-Series Barra, but it's got an FG sump on it, which is modified, and you can see this extra oil pan depth, and that's for the pickup. This was one of the earlier conversions done, so I think the guys sort of had their reservations about oil pressure and four-wheel drives on an angle. That's why they added this. We'll see if it fits, but we might have to make some modifications ourselves. As far as performance goes, this one's got the standard mods that you'd generally do to a Barra, which is oil pump gears, heavy duty timing chain, valve springs and head studs. This one's probably got the next level of upgrades as well. It's got heavy duty rods and pistons in it, which means we're able to extract a little bit more power, and the motor's probably good for around 1,000 horsepower. It's also got Crocam regrinds in it as well. Looking at the hot side now, this is a flipped B-Series manifold and we're using a ProCharge 67mm turbo. On the exhaust side, this turbo uses the Ford housing and then it's got a new compressor and internals on the front end. This turbo is also capable of up to 1,000 horsepower. Looking at the cold side now, and we're using a standard FG intake, but the water methanol system is drilled and tapped into it. The water methanol system drastically reduces the intake temperatures to the motor, and it gives you the ability to make a lot more power on regular octane fuel. As far as the serpentine setup goes, we've already got a high mount alternator on this, which is excellent for four-wheel driving. I think we'll probably switch out the kit for one from Barra of the World because I'm not quite sure where to get replacement ones of these. Barra of the World does a really good kit without an extra idler wheel there. Now there are a couple of weak spots on this serpentine setup, like the plastic power steering pulley, and if you're at high load and wide open throttle at low speed, then generally there's not enough ventilation from the air and they do have a tendency to melt. So we'll swap that out for a metal one. And there's a few other little bits and pieces that we'll do just to make this thing reliable. That's the primary goal of the build, really, to make a reliable powertrain. We're not really chasing numbers as such. At the end of the day, this car's got to go to remote places and we don't want to be worrying if there's going to be a powertrain failure. This is a ZF 8-speed from 8speed.com.au, and those guys are doing a bunch of wild 8-speed conversions at the moment behind pretty much every car on the market. This particular ZF8 is built and it's rated to 1600 Newton meters, so it shouldn't be a problem for the amount of torque that Barra's putting out. My good friend Macca had one behind his VDJ in the 79 series, and I was thoroughly impressed with that. So if that's anything to go by, then this should be pretty good behind the Barra. We've got some other goodies from 8Speed AU for this build. This is a DCT shifter, which is a sequential shifter. We've also got the turbo Lamp TCU. Now this is the brains of the 8Speed. From my OEM experience, controlling a transmission isn't easy. It takes thousands and thousands of road hours to sort of calibrate and to get the drivability right. But this thing is supposed to be pretty good, and I know it's pretty good because I've been in a car with it before. So I'm really keen to see how it goes behind the Barra. It's got some really cool functions which we can't get on the ZF 6-speed, and we're gonna cover that in later videos. But for now, this is everything we need to get our 8-speed started.
All right, enough explanation, time to test out this Billet Bellhousing adapter.
Just bolted up the billet alley one for the first time and it looks really good. I think there are a few little tweaks we'd still do before a production one, but this is definitely just a prototype. But I think we'll be able to use this one on the build if we can bolt the transmission up to it, which is what we're gonna do now. Ready?
What did you say?
Isn't there one here?
George, I don't get paid enough to be a new model.
That's the first test fit of this ZF8 onto the back of the Barra using this Bellhousing adapter, and it's pretty successful on the whole. On my channel, we genuinely do make a lot of mistakes, but stuff like the 3D printing has allowed us to get this right the first time, and that's what you want to do when you're machining billet alley because it's pretty expensive. So there's a whole bunch of modern tools like the 3D printing, which is really making our lives easier to get prototypes right the first time, and it's awesome actually. Now we get to bolt on the petrol transfer case. And someone just handed me this. Have a look at that. This one is special for the build and it's been anodized black. Normally they're left raw, but I think this looks pretty awesome. And it's gonna look pretty special on the back of this ZF8.
We're using a petrol transfer on this build to suit the petrol diffs. A wise man once said, under every good Toyota there's bits of Nissan, in reference to the driveline of course, and not the engines. I run GU diffs with standard TVs on my car and have never had a problem. To suit a high horsepower motor, they're an obvious choice. With that in mind, let's hand it over to Ash, who's going to install the petrol transfer case.
Fitting up the Nissan Patrol to ZF8 transfer case adapter. Special mention, these input gears for the transfer case, made brand new here in Melbourne by Hardman Brothers. I am the only one, to the best of my knowledge, that has these manufactured brand new. All the others typically have the splines, these splines machined out and re-splined. That comes with a lot of complications, damaged gears, changeovers, etc., etc. So I figured, let's spend the money, let's invest, make brand new gears, quick changeover. So let's get into it. Start with taking the front cover off. This one's the culprit here. This is the one that we want to change. There are half moon needle rollers on the inside of the gear, so we just need to be careful that they don't fall into the transfer case. Remove it carefully. So that'll just slide out. These two here, you'll see the two needle rollers I was talking about. So we'll just take that cage out. We'll place him up there so we don't lose him. All right, let's go press a new bearing on. Got the two gears side by side between Nissan, ZF transmission, 43 spline, they're all the same. Most of them are the same. What we're going to do is we're just going to take the circlip off, press the bearing onto the new gear, and we'll slip him back in. So let's go. Circlip off, new bearing, new transfer case input gear. So we'll just press him on. Very important before I go press it on is we're going to press the inside sleeve, not the outside. We don't want to press on the rollers or the bearing. See how I reckon, mate. Right. Whilst we've been doing this, George has cleaned the surfaces up so we can just slip it back in, glue it up, good to go. Worth noting that the lay shaft has a sort of like a synchro gear. If you can see very closely in there, see that the top plate comes over the gear, which will nearly make it impossible to get the input shaft back in. So what we need to do is we'll just rotate it so the lay shaft has a nice clear access. A little bit of grease on the half moons on the inside. And what we'll do, this will help hold it up. Job done. Now time for the top cover.
Bit of sealant.
Bit of sealant. All right, I've always found a good practice. A little bit of grease just inside the seals as well. On the inside of this seal here, so. Yeah. Time to bolt this bad boy on. So these are made in Australia, made right here in Melbourne as well. So this actually has positive alignment around the outside of the case. This is actually machined here, so perfect alignment every single time. We have two holes that are basically opposing one another. It's got to slip a stud into the transfer case here. That's for you.
That's the Patrol transfer all bolted up, and we are ready to put the powertrain in the car, which is really exciting. We've got the barrel on the gantry now, and we are good to go. So let's put this engine in. Probably not for the last time. I reckon it'll go in and out 10 times throughout this build, but let's put it in for the first time.
Like just manhandle it around. I'm going to go around the pilot chassis.
Right, come forward.
Oh, big, strong Aussie boy.
Aussie boy.
The GoPro time lapse is just of George's bum.
Oh, no.
Yep. Me.
So the engine's pretty much in, and this is the tedious bit. This build is a blank slate and there's no bolt-in kit available for what we're doing. Here, we're making minute adjustments for what seems like an eternity until we're happy with it all. Once it's all done, I'll explain exactly how we came up with this final engine position.
Alrighty, so we're just welding a temporary member under here, and then we can get rid of the gantry crane and weld in some engine mounts. We are happy with the engine position after about 5-6 hours playing with it. There are so many considerations to take into account when you're doing this, and basically everything's a trade-off. A big one for us actually this time was Barras do have a tendency to crack manifolds, and we've seen it in a lot of conversions with using aftermarket manifolds and homemade ones. So they do crack, so we tried to keep a stock B-series one for this. And the problem with that is it actually mounts everything a little bit further back, and then we've got dump pipe clearance on the firewall to worry about. But what we've done is move the whole engine forward, and that's actually not a problem with this build because we're doing rear mount radiators and we have a bit more room for packaging up the front. Another big one is driveline angle. You obviously want them to be as straight as possible so it doesn't put premature wear on the uni joints. I guess for us, the powertrain's on a 4-degree angle now, which is pretty good, and it means that our front tail shaft won't be on a crazy angle as well. Another huge consideration is suspension performance. We want the sump to clear at the front, which means we want the motor up, but you also want the motor as low as possible for center of gravity and vehicle handling. So it's just a massive trade-off, all of these things. Another one is side to side. We just want front tail shaft clearance with the box and the engine. So our motor's a little bit offset or on an angle. The center output shaft is at the center of the chassis. I think that's probably it. There's just a huge amount of considerations and everything is a trade-off, but we are really happy with this now and we're gonna go blaze on some engine mounts.
Sorted.
Engine mounts, Richie. Heavy duty mounts. They're like captive, so it's like a 6mm wall crush tube with a urethane bush. So they're pretty firm. You wouldn't want this in like a daily drive car. You'll feel the vibrations through the engine, but on George's, it's perfect, super strong. Pretty close to solid mount. You'll get a little bit of dampening. 40 MB tubing. We want to house that half over the top and half over the inside face of the chassis rail. What we need to do is get a measurement from the long point of the notch to where we want the outside of our tubing to end, and then we can measure the degree with this fella, know what angle to cut it on. There you go, that's on a 20-degree angle there. Now, being the labourer, mate, get on your grinder and go and cut that for me.
Woo-wee! We're on! Look at that, mate. That's the first time, right?
Yeah, that's right. One cut. That's not going anywhere.
For the moment, we've just tacked the inner part of the engine mount. The bushes need to come out for a full weld off, otherwise they'll melt. Oh damn, how good does that barrel look?
Mate, you didn't shake it. You gotta give it a good nudge.
Yes. That's not going anywhere.
Thanks, Loz.
The cab comes off to enable easy access for a custom fabricated crossmember we're about to make.
Today we're going to build a custom rear cross member for George's build. We're using the Fusion Fab transfer case adapter. Ash supplies this, say if it's going into a patrol with patrol style rubbers, to go in direct bolt into a Nissan cross member. For the application at hand, we're using heavy duty front mounts. We're going to use heavy duty rear mounts to suit. We're going to plasma cut a mount to suit the member, and we're going to use the rubbers. Are going to be mounted to the chassis each side, so it's a removable cross member.
Laurie is now putting the heavy duty mount together before he starts measuring everything up.
All right.
Yep, perfect.
And the plasma table makes its first appearance in this episode. I know you're all probably getting a little worried, but here we're cutting out the bottom of the transfer case adapter mount. The mount now gets some folds on the V-block press to suit the transfer case adapter. And the 40 NB crossmember was cut to size on the bandsaw before receiving a notch on each end for the bush housings. And now Laurie is welding the bush housings to the freshly cut and notched crossmember. The plasma table gets another call up to make some chassis brace plates where the crossmember will be mounted. You can see here the crossmember brace plates are spaced with window packers. Once we're happy with the position, the transfer case adapter mount can be welded onto the crossmember. The crossmember mounts get cut out on the plasma table. There you have it, everything tacked into position. The crossmember gets unbolted and bracing is added between it and the transfer case adapter mount. Crossmember braced. A slightly oversized crush tube is added between the crossmember mounts before they are fully welded off to ensure they don't pull in. Extra welds will be added later when the chassis is fully welded off, but for now this will do. Look at that, simple and tidy.
Got it? Is that right?
You'll notice the crossmember isn't hanging below the chassis rails, which is a good thing for not getting hung up on the tracks.
So that's the tube crossmember done for now. We're going to add some additional bracing to the mounts once we confirm the front tail shaft location. But for now, she's not going anywhere.
Now that we have engine mounts and a crossmember mount, I'm cutting out the temporary support members.
Engine, gearbox and transfer are now supported by its own weight, which is amazing. And we're going to end the episode there, but make sure you stay tuned next time because we've got suspension and bar work coming up and this build is really going to start taking shape. If you enjoy this content, guys, don't forget to hit like and subscribe. Really appreciate it. Cheers.